and Polytechnic College also I have done my lectureship. And for
Okay,
few months I was in the structural firm, which is in Vashi for designing of the bridges.
okay, okay, okay.
After that, I have taken a long break. So due to which I have lack in the knowledge of the structures. So
Okay,
I want to enhance and I just want to rejoin in the structure field.
okay, okay, fine, fine, good, good.
Thank
Yes,
you, sir.
actually, in our training program, we are going to do that. Total perspective will be clear to all of you, definitely. Then, Miss Sulekha,
Yes, sir. Good evening.
good
My
evening.
name is Sulekha,
Yeah,
and I am from Kerala.
yeah,
But now,
okay.
currently in United Arab Emirates, in Sharjah.
In Sharjah,
Um,
okay,
yes, I passed out in 2005 from Kerala MG University.
okay,
Um, from that time, I was continuously working, and in India, I mean Kerala, I worked 3 years. Then I came to UAE. After
okay,
my marriage, I came here,
okay,
and still I am continue my work here. But the problem is I am here. The consultants category is G plus 4, means I am
okay,
working in a G plus 4 category. So
okay.
I want to make myself updated like unlimited or G plus 12. So
Okay,
I want to write
management.
the
Yeah.
yes. So I want to write the exam to pass from Dubai municipality or Sharjah municipality.
Okay, okay,
So for that that is my intention, so that I can join a good consultant and I
yes,
can
yes,
update my career.
yeah, surely, definitely, this will help you because ETAP, Safe, and all the other these softwares are actually essentially in UAE, in Dubai,
Yes,
Abu Dhabi. If you want to work in Middle East, definitely,
yes.
because that is the actually process.
Mm.
You may need to little upgrade on British code also. We will guide
Yeah.
you separately for that. If you need any
Now
upgrade,
they yeah,
yeah.
yes. British Code was practicing here before, but recently they changed to ACI. Usually, I mean ACI is now practicing more here now.
ACI generally they are using for American codes for earthquake engineering mostly. Currently, they
Uh,
have changed it. Is it so?
yes, yes. So now G plus 4 also means our consultant also must follow ACI,
Okay,
all
fine.
ACI. Yes.
Okay, fine. Okay, and then UBC code for maybe this
British code
earthquake.
also using, but the municipality will prefer for approvals. They prefer ACI now.
ACA. Okay, okay, fine,
Yes.
fine. Okay, no issue. Uh, thank you.
Thanks.
Anything else? Anybody? I think Avinash Singh. Yes. Hello.
Good evening, sir.
Good evening.
My name is Avinash Kumar Singh from Patna.
Patna. Okay.
Last year, I was completed my MTech Structural Engineering from Rabindranath Tagore University, Bhopal.
Okay.
I just 18 year. I have 4 year experience in the field of construction.
Okay. In the field of construction. Okay. And you want to get the structural engineering knowledge.
Yes, sir.
Okay. 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 Thank you. So thank you all for your introduction. Actually, it is better to know each other because see there are many team people from India and even outside India. So I just took this 5 minute session for all of you. Okay. So let's continue today our this topic, which is life cycle of project. Let me share my screen. Is it visible?
Yes, sir.
Okay. So last time we started from this client, then the land survey, geotechnical survey, and architectural planning. I think so. All these 3 points are covered. And once the geotechnical investigation and architectural planning is done, then we should go for the structural part. So this is actually major structural part. So whatever projects we have generally get in any field, it may be building, water tanks, or steel structures, they are within this framework. And our training program is also based on this training, this framework only. So this is the zone where we are going to learn a lot of things. So almost 80 to 90% knowledge in our training program will lie within this frame, and all other basics will be covered definitely regarding construction, architecture and all. But mostly we are working here. So we need a lot of knowledge within this framework. It may be basic concepts, it may be practical application, it may be software knowledge. This is within this only. So this is, we can call it a generally structural department. So any consultancy firm, it may be local consultancy, multinational companies, whatever, they are having structural department within their organization, and that structural department works in this framework only, and they coordinate with each other. So this structural team will coordinate with architects, geotech people, client, then contractors, and survey part also. So they interact, and then there is one more agency which is nothing but MEP. So they need to coordinate with all these people. So whatever output these people are giving is very much important for the structural department. So either we get architectural drawings, either we get geotechnical reports, or we get contour survey drawings. That they are important for our planning, designing, all these aspects. And also we need to understand the construction and contractor problems so that we can give good solutions to them. And we need to check the reinforcement and all other things on the site also. So this is our part. Now we will just see in brief today regarding the structural department. So what is structural framing, analysis, design, drawing, like this? We can say a role of structural engineer in general. Okay, so can anybody tell me what is the role of structural engineer? You know. Yes. Role and maybe responsibility also. Anybody? What is the role of structural? What structural engineer is doing?
To check the stability of the structure under the given loading.
Okay, so it's checking the stability. Okay, then what else he's doing?
Analysis and design the members,
Yes.
building member.
So he's doing the analysis of the structure, either building or tanks or steel structure or any other structure. He's also designing the structure, designing of the structure, design of structure. And what else he's doing? He's doing the drawings also, no? Structural drawings, preparation of structural drawings. Okay, what else?
Preparation of detailing.
The drawings and detailing, let's say in detail. He's also doing BOQ, actually quantity estimation for RCC elements, RCC part. So because structural department is responsible for structural quantities. So RCC part mean we can say quantity of reinforcement, quantity of concrete, shuttering, excavation, like that. So basic part of the structure we can say. And generally the finishing part like painting, doors and windows, these BOQ is prepared by the architects mostly in general, or there may be some separate civil engineering team for preparation of BOQ. But structural engineer is giving RCC part BOQ also. So this is in general the role of structural engineer, and definitely coordination with all vendors. And what is the responsibility? What responsibility he is carrying out? What is the responsibility?
Sir, the site engineer can consult, I mean, get ideas if he is having some doubts regarding the execution from
Yes,
structure.
this. So they. It comes in the coordination. They need to coordinate within the team. It may be vendors, site engineers, architects, or whatever. You need to coordinate with them. And what is the final responsibility of structural engineer?
The structure should be safe and
Yes.
stable.
So he is responsible for the safety and stability of the structure, we can say. Stability of the structure. Because see, finally he needs to give the stability certificate. Okay. So he has to sign that certificate. Stability certificate. So in general, these are the roles and responsibility of structural engineer. Now we will see each and every term in detail actually. Within that responsibility actually, what parameters he is considering in the design and analysis. So whenever he is doing the design analysis and drawings, what parameters he is taking care of? Anybody knows this? Means parameters considered while designing. Yes.
So considering dead load and live load on the structure.
Okay, so that will go in detail. In totality, I'm just asking. For example, let's I will give as we have already discussed. He's considering the stability of the structure first. Okay, so this is one of the parameter. Stability of the structure. What is the second parameter?
Strength.
Strength. Yes. So strength of the structure or member, we can say strength of members. Stability of structure. Else. What else?
Safety.
Yeah, safety, but whenever you consider all these parameters together, it is a safety, we can say. So a technical term I'm trying to use here because the every technical word has a meaning. So safety means if you take care of the stability strength, then you can say your structure is safe. Okay, so safety is one word, but let's put it separately for the time being. Okay, next.
So durability.
Yes, durability is one point. Durability. Then one more. Serviceability. I think you know this word. We have learned in the IS 456. Serviceability, durability. What else? Cost. Whatever solutions you are giving, they should be cost effective. The cost of the project should be optimum cost, we can say. Should not be high. So you must consider the cost also because this is very important parameter actually in any field actually. What else? Any point you feel it is required in designing? Hello. Hello, am I audible? Hello.
Yes, sir.
Okay.
Audible.
Yeah. So then there is one more point which is related with the functional part. We can say synergy. We'll see in detail what do we want to understand by this word. So in general, these are the parameters which you should consider while designing the structures. So designing, whenever I say designing, we are saying a structural design, because it is part of the structural department. So whenever we design any structure, we are taking care of the stability of the structure, strength of the member, serviceability, durability of the structure, cost of the structure, and synergy of the structure, we can say. So we will try to understand each and every word in detail now. See, as I told you, we are trying to understand the structural part of the life cycle. Okay. And it starts from the role, and then we are going in detail in this topic. I'll show you that structural department workflow also after that. First, we'll focus on these terms. Okay, so what is meant by stability? Yes. पता है कि स्टेबिलिटी का मतलब क्या है?
The structure should be stable after considering all loads.
Yeah, it should be stable. Yeah, so now see, you'll see that there are terms like safety, there are words, we can say words. There is a word like stability, there is a word like strength. Okay, so but in technical terms, we should understand what is meant by exactly stability, what is meant by exactly safety, or what is meant by exactly strength. Okay, so every word has a meaning technically. So okay, for loading, the structure should be stable. Now let's see what is meant by stable. See, stability means, in general, we can say that structure should not collapse. Structure should not collapse. So this is very important word in this. Now, once you know the purpose that I want to design the building such that structure will not collapse. That is meant by stability. Now you should know how you will make sure that the structure will not collapse. So for that, we should know the examples. Can anybody tell me why structure fails actually? Or collapse, what do you understand by structure will collapse? Collapse of structure. इसका मतलब क्या है? समझो स्ट्रक्चर कोलैप्स हो रहा है, मतलब क्या हो रहा है?
Fall down.
Yes, fall down, we can say. Directly collapse means fall down, let's say. Okay, no, fall down. Say if there is a structure or building, let's say, and there are cracks in the beams or there are cracks in the columns, can you say that the structure is failing or structure is collapsing?
No.
If there is crack, we cannot say that it is collapsing. Okay, it is may not be safe, but we can't say that it is collapsing means directly falling down. Okay, that means you should know what may be the reason of falling down or collapse of the structure, and that once you understand the reason, then you can take care of the stability part. So let's take an example of simple example. Let's take I ask you one question. Simple question. There is a one frame like this, and all joints of the frame, they are pin joints, okay, pinned or hinge. All joints are pin joints, and I am applying horizontal load here. What will happen to this frame? Yes.
Sir, it will sway towards one side.
Okay, it will sway. So I'm just asking you this question. Will it sway like this? Is it so? Hmm? Do you think so?
Yes, sir.
Yes, sir.
Yeah, you are partially right, but all joints are pin joints. And this diagram, red color diagram, we can say it is a side sway. Okay, lateral sway, side sway, you can call it as. But if all the 4 joints are pin joints, actually what will happen, that you should know, and that is nothing but, so it will not sway, it will directly collapse like this. Okay. So sway means we can say there may be permissible deflection, lateral deflection, but this is not permissible. It is directly collapsing. Even not this, it may even fall down. So it is as good as falling down. Yes or no? Too much sway. We can say too much sway. Too much sway means directly collapse. Okay. See why it is happening, because all the joints are pin joints, and it will fall because we don't have any restraint developed, because all joints are pin joints, and therefore it is a total collapse of this frame. Then what you will do once you understand what will happen due to this we can say arrangement. So why the structure is getting failed? Kya lag raha hai? In general term, why it is failing?
Not proper joint, notly proper joint.
Oh, yes, so joints are not proper. So if you want to make it stable, so yeah, so whenever we say it is a collapse, we can say it is an unstable structure. Okay. And we cannot design unstable structure. Please try to understand. If you want to design any structure, it should be stable first, then and then you can design. Okay. You cannot design, you cannot analyze unstable structures. So before going for any analysis, you should make sure that your structure is stable. Now, if I ask you, if you want to make this structure as a stable structure, what you will do?
Make the support fixed.
Okay, so this is one of the way we can say. So we can make the supports fixed. We will learn what is meant by fixed support and how it is taken care in practice or something. For the time being, let's say use the word fixed support. No worries. Now, if I apply the lateral load, what will happen to this? Will it collapse like this?
No, sir.
No.
No, sir.
Okay, but what will happen to this then? Will it
There
deflect?
will be permissible deflection. Permissible
Yes,
deflection.
yeah. Okay, so see, I'm just using now simple and easy term, let's say. The deflection will be little different, but just for this session, let's take. So there will be deflection. I can say it is delta deflection. Okay, delta. So there will be deflection, but it will be within permissible, which we cannot say that it is a collapse. There is a sway, so this we can call it as a sway, lateral sway, but it is within limits, then it is okay, no worries. So let's say delta is 1 mm, 2 mm. So for this load, it's okay, acceptable. How to make it acceptable, how to check it, we can study that. So for making stable, you have made all joints as a fixed joint. So this is the care you have taken while preparing the form of the structure or shape of the structure, we can say. So you are creating this form or structural framing arrangement such that the structure is stable. So you made it fixed joints. Any other choice you can have to make it stable apart from making fixed?
Sir, stiffness can be increased of members.
Bracing can be done.
Yes. So bracing is stiffness only. See, if you increase the stiffness of these beams and columns, will it help? करेगा क्या help? If this is the case, and you are making the increasing the stiffness of columns and beams, will it help to avoid this collapse? Yes or no?
No.
Actually, no, because all joints are pin joint. The instability is generated due to these joint conditions. So whatever joint condition, if you don't have the sufficient joint conditions, then the structure will collapse. So even though you increase the member stiffnesses, it is of no use. Now, second option, you said that you can make it stable by using the bracings. Now, whenever you use bracings, so let's say I want all the joints as a pin joints. And now you understood now that if all joints are pinned in this frame, then it will collapse. But I want all joints as a pin joint. Still, I want to make it stable. So as you said, you can make it stable by adding the bracings. Okay. So will it be stable now? Yes. Will it be stable, this structure? See, this bracing will now help to resist the lateral deflection. So which force will come in this? कौन सा force आएगा इसमें?
Axial.
If you yeah, axial force will be there, but if you push this, will it be tension or compression?
Tension.
No, see, you are pushing this here. So this will be-
Compression.
so it will be actually compression.
Compression.
Because
There
you
will
are
be
yeah, so this is trying to go here, so it will be compression. That means even though all joints are pin joints, if you only add this diagonal member, this will create compression in this member, and this compression will resist this horizontal deflection. So there will be horizontal deflection, but it will be, or it may be within limits. It will not collapse, we can say. So this will be something due to this bracing, we can say. Or there is a bracing, there are different types of bracing. You can have only all joints are pin joints, but you can have like this also. So what force will come in this? कौन सा फोर्स आएगा इसमें? ये डायगोनल टेंशन. हाउ यू आर अंडरस्टैंडिंग इसमें टेंशन आएगा या कॉम्प्रेशन आएगा? आपको कैसे पता चल रहा है?
डायग्राम ट्रांसफर, लोड ट्रांसफर.
सी, ये भी डायगोनल है, ये भी डायगोनल है. आपको कैसे समझ में आ रहा है कि ये है कि
what type of force is coming on the hinge by looking at the arrow? Then we can tell if there is compression or tension.
See, visually, see what happens whenever we learn anything. we can understand the concepts which we can see through our eyes or observation. See, after mathematical calculations, if you are getting the things, then there may be mistake also. So if you do plus minus in mathematical calculation, there may be possibility that tension will become compression or compression will become tension. Now for these images, you can see visually imagine, or you can create your own experiment, like creating this frame and just pushing this, okay, physically. What will happen whenever you push this frame? You will see that this diagonal length is getting increased. Okay, so previously the length was this. Let's say it is 4 meter. Just I'm taking it for example. And after the application of force, this diagonal got increased to 4.2 meters. Let's say. So whenever there is a elongation in any member, what do you understand by elongation? When it elongates,
When the
when the
member is in tension.
tension. So जब tension में रहेगा तभी वो, we can say that it is elongating. So you are understanding through elongation of this member. So you can see visually that previously this was the length, and once you apply this force, you can say that it is elongating. And as it is elongating, that means there is a tension within that member. Similarly, if you see here, and if you apply the force, you will see that this length is getting decreased. Let's say previously the length was 4 meters, this one. And after this application, you can visually see that, let's say it becomes 3.8 meters, let's say. So it got reduced, and that's why there is a compression. So in structural engineering, many times I have seen that people or candidates find difficulty in understanding behavior of the structure. So behavior you can understand only through visual observations. No software or no any book will help you in this. Am I audible? Hello?
Yes, sir.
Okay, fine. So if you want to understand the behavior of the structure, you should know how to see the structure, how to visualize the structure. Okay, so this is very important. And visualization means you can see through your eyes. That is the visualization. I'm not saying that you should know the mathematics. I'm saying that you should be able to observe the structures, observe the images. You should be able to draw the sketches like I am doing this. And once you do this, then you can definitely understand the behavior of the structure. For example, what will be the bending moment diagram, or what will be the deflected shape of the structure like this. Okay, so we will go in detail in upcoming sessions. So stability means, okay, and there may be, we can say, now as a common sense, I'm just trying to ask you one more question. Third case may be also possible. Double bracing, X bracing or cross bracing, we can say. Now tell me which, abhi, see, there will be delta deflection, delta 1, let's say. Here it will be delta 2, and यहाँ भी deflection आएगा हमारा. ये lateral deflection रहेगा ना. Let's say delta 3, ये. Okay. Can anybody tell me which frame will have more deflection? किसका ज़्यादा रहेगा और किसका कम रहेगा? Let's say this bracing, this frame is of steel structure. Steel structure का frame है, आप समझो ये. Now tell me which, ये steel structure है समझो. All frames are steel structure. Yeah, we are just talking here, huh? Steel. Which frame will give more deflection and which will give less deflection? Yes.
Number
So
two
the
is
third
the
one will give least deflection, and the second one will give highest deflection among the three.
No, see, these members are steel structure members, all members. So will this give more deflection than this, or ये देगा first वाला? Think. See, I think conceptually you know that steel structure, let's say there is a steel structure here, and if you apply the load, there is a compression, you know. And do you know that when the member length is more, generally steel member buckles, okay? So as it is a compression member, it will try to buckle, isn't it? Yes or no? Compression steel member tries to buckle, or any
Yes, sir.
actually, yeah. So whenever it has a buckling tendency in steel structure, definitely this will have less capacity. So actually it will it may see deflect more, so it will be more deflection. And as this member is steel member and it is in pure tension, so definitely it has a pure tension capacity, full capacity, so it will deflect less actually. So this will be the middle deflection. Delta 2 is middle, delta 1 is very high deflection, and delta 3 is very less. So I can say that the stiffness of this frame is more, lateral stiffness is more here, and it is very less over here. Okay. So whenever we learn any structural engineering concepts or any word in the structural engineering, see, there are words like buckle, there is a word stiffness, there is a word deflection, there is a word stability, there is a word strength. So each and every word you should understand from the concept point of view, from basics, because if you confuse the words, then your understanding will be confused. Okay. So through started with the stability part. So how you are taking care of the stability? So what is the आपने क्या किया फिर? Hello? So in stability, mainly we are concerned about the joint or supporting conditions. Okay. So joint or support conditions are very much important in stability. So you should make sure that your structure is safe by giving appropriate joint or supporting conditions, or in technical terms, what word we use in this joint or supporting condition? What is the word? Technical word? Yes?
Stability.
No. We can. The technical word is boundary conditions. So if you want to make the structure stable, make sure that your boundary conditions or joint or support conditions are having relevant supports. Okay, so either it should be fixed. Fixed is always good. It gives more, we can say, stiffness to the structure due to the all joints are fixed. And if you want to make the steel structure with hinge joints or pin joints, then provide bracings within that. Either X bracing, A type bracings, or single bracing like this, tension bracing or compression bracing. So you can use this for making structure stable. Now, see, these are the conceptual part we are learning. Then after that, you should know how to apply on the real projects also. What care is taken in the structures, real structures. I want to ask you one more question. Now let's say this frame, you said that all joints should be fixed. I again ask you one question. Let's say this is your pin support, okay? And these two supports are fixed supports. Is it stable structure? Yes.
No.
Now I want to ask you a question. How you are saying that something is stable or not stable? Okay. Now One is that by a general judgment, we can say engineering judgment, or by visual observation, general, you may say. Okay, so second question, if this is the frame and this is the frame, which frame will give more deflection? Ye wala, this one, or this one? Who will deflect more?
Second one, pin joint deflect more.
Yeah, this will deflect more. So let's say this will be your deflected shape, we can say. So delta 2 is more, actually. This will be more than this compared with this. If all joints are fixed, then it will deflect less. It will deflect more. Now see, something is stable or unstable depends on this deflection. If this deflection is very high, very high, then you can say it is unstable. Now if you want to check whether this frame is stable or unstable, you need to calculate actual deflections, then compare with permissible deflections, and if they are exceeding permissible deflection very high, so let's say permissible is 10 mm and your deflection is, let's say, 1 meter, just taking, or 500 mm. So this is very high deflection, and you can say it is not a stable structure. So you need to calculate these deflections to check whether the structure is safe or unsafe. This structure you even not need to calculate, because see, this is going to fall down definitely. Yes, it's a very, we can say, common sense. Through that you can understand. In this case there is a little confusion actually, because these two supports are fixed supports. That means they are going to give you certain stiffness. So I may not say that it is an unstable structure, but, and even I'm confused, we can say ki ye purely unstable hai ki nahi, I don't know. For that I need to calculate the deflection through analysis, either manually or software, and then I will give the stamp that it is stable or unstable. So there are many times there are obvious things like this. Obvious means definitely it is going to collapse. It is a common sense. But here there is a little confusion, so it is better to calculate. Here it is, there is no confusion, because you know that it is very stiff structure, because all joints are fixed. So many times through common sense we can give certain judgments where you are 100% sure, and where you are not sure, then you should calculate that, and then you can give your judgment. So this is, in general, we can say, a stability of structure. And a simple example we can say. So there is one more example, let's say instability structure. I'll just tell you. समझो एक cantilever है, there is one cantilever. Okay, and then there is a one. This is a cantilever, let's say. Which is connected to this wall through this pin. Okay, one bolt, we can say. Is it stable or unstable?
Now it will rotate.
Yeah, it will rotate like this. ऐसे कुछ तो गिरेगा ही, मतलब almost. It will rotate. Too much rotation. Is it stable? Yes. Stable है या unstable है?
Unstable.
So it
Stable.
is unstable structure. Now you can understand that mostly the stability is related with the joint or support conditions. Okay, mostly. There may be certain additional things, but in general, we can say in structural engineering, the stability is something related with the joint conditions, supporting conditions, or boundary conditions, we can say. So before creating any model in structures, make sure your joints are such that it makes the stability. Okay, so this was the word stability, first type word. Now I will take, before strength, I'll just go to the serviceability first. So what do you understand by serviceability? सर्विसेबिलिटी का मतलब क्या है?
So if the structure is providing the functionality properly or not.
Yeah, functionality means what are the functionality points? Technically,
Mean
what are those points?
if it is not deflected or there is no crack or it is
Yes.
not disintegrated.
Yeah, so there is not much deflection. So deflection within permissible limits. Okay. So permissible deflection is one point in serviceability. As you said, there crack width should be limited. So limited crack width we can say, or we can say permissible crack width. Permissible. So these are the actually two terms which are important from serviceability point of view. And if you want to check the deflection of the members or structure, then you should know how to calculate the deflection of the structures, and you should check with the permissible limits. Now tell me, we'll take the example of the same structures here. Now let's say this is your case. ये case है समझो. A structure ये. Now let there is a force 10 kilonewton या कुछ तो force है समझो. So it is going to deflect. So there will be delta on deflection. So let's say this deflection is 10 mm, let's say. Now, how will you understand whether this deflection is permissible or not? Where will you get the information regarding the permissible deflections? So 10 mm okay है या नहीं है? How you will understand this?
From codes.
Yes, from codes. So code gives the information regarding the permissible deflections. So either they are lateral deflections or there is a deflection which is vertical deflection also. So due to dead load, lie load, there is a deflection. And there you will get. So how you calculate the deflection? So we have learned that in the engineering, the calculation of deflection, calculations of members. अभी इसका deflection निकालना होगा तो कैसे निकालेंगे आप? So manually in frame deflections, you can get it through the books actually. The methods are given, but nowadays, as you can use your softwares, you can directly model this frame and just put the loads and you will get the deflections. If you want to calculate the deflection of simple members, see, as the structure becomes complex, it is very difficult to calculate the deflection manually. If I ask you to calculate the deflection for, let's say, a simply supported beam, can you calculate this? Let's say there is a simply supported beam and there is a vertical load W, okay? And this is EL. Can you calculate the deflection? Vertical deflection like this. Yeah, ऐसे कुछ तो deflect होगा ना vertically. So there is a delta like this. Getting this? So if the structure is simple like determinate structures, we can say, then we have already the formula available in books or ready reckoners. Like this, I'm just giving example. WL raised to 4 upon EI. So these are the example. So for different loading condition, for different boundary conditions, if it is a pinned support, this is the deflection formula. Then if it is a fixed support, the formula is different. If it is lateral load on the frame, there are formulas given. So you need not to remember everything. You can have your ready reckoners and books along with you. We will share with you this deflection formula and all. You should know, you can either get it through these formulae given in the books, or you can model this structure in the softwares like STAAD or ETAP and get the deflection from the software itself. So these are the methods of we can say calculation of the deflection in structures. Once you get the deflection, let's say after calculation you get the deflection, calculated deflection as 10 mm, let's say, and you will compare this with codes, IS code. IS code has given the deflection formula, limits. We will see in detail in our upcoming session as we go in detail of each and every point. Now, second question I want to ask you. So either it may be vertical or horizontal. Now, why the deflection should be within the limits? Let's say there is a load, this is a bedroom, let's say, and there is a load like this, and the beam deflects like this. And this deflection, let's say it is nothing but 200 mm. Okay. This is a bedroom, let's say. Is it okay to have this deflection? As a structural engineer, I have designed this frame. Actually, and I have put more steel in this. Then grade of concrete is also very high. Only the deflection is more, which is 200 mm. Will you really be happy to stay in this kind of room where the beam deflection
No,
is
sir.
200 mm?
No, sir.
No. So what is the reason for that?
Safety.
First of all, there is a psychological tendency, and aesthetically also it is not very. We can see there is a lot of deflection. So
Yes, psychological condition, actually, you are right. And aesthetic also good. Functional part is because there may be problem to the plaster or some objects connected to that. Okay, that may fall, they may fall, or they may have we can say deflections. So psychological fear is there. Actually, you are not feeling comfortable staying in this room. You may feel that it will collapse down. I know that as a structural engineer, I have put steel and concrete such that the structure is not going to crack and fail. Only the deflection is more. But still it is not okay. Even though I say, you will not believe, because psychological there is a fear in your mind. So this is not serviceable. That means by considering all these parameters like psychological and aesthetic and functional part, the code has given the limits of deflection. Generally they depend on the, we can say, span generally, or height of the structure. Let's say this is L. So I can say permissible deflection vertical is say L upon, for example, L upon 350, let's say. So if your L is, let's say, 3.5 meters, okay, 3500 mm. So what is my permissible deflection? 3500 mm divided by 350 means how much? 10 mm.
10 mm.
So for this span, generally 10 mm is accepted as per the code, we can say. So if your these calculations are giving the deflection, let's say 20 mm, समझो इसने 20 mm दिया ये deflection, तो is it okay? 20 mm अगर दिया तो does it satisfy the code?
No, sir.
नहीं, because see, code is saying maximum 10 mm चाहिए, यहाँ तो 20 mm है, so 10 is not okay. Let's say your calculation is giving 5 mm deflection, is it okay?
Yes, sir.
Okay. So this way we generally check, and what we are doing in this is nothing but a serviceability check, which is more related with the deflection part. And for that you should know the codes, and you should know how to calculate the deflection of the members. So we have seen the serviceability, and one more thing is there, crack width calculations. So when there is a beam, let's say ये beam है हमारा, this is your beam, and do you know what is the permissible crack width as per the code? कितना है पता है क्या? Permissible crack width.
.75D.
No, it's simple. We can say in limit states, as we in buildings, we can say 0.3 mm is the permissible. So whatever our IS code is prepared is depending on the 0.3 mm permissible crack width. So okay, so we don't exceed this. Now can anybody tell me why the crack width is permissible? मतलब क्यों चाहिए हमें ये? ज़्यादा crack width रहेगा तो क्या होगा?
There will be chance of corrosion to the reinforcement.
Yes, there is a chance to the corrosion. So let's say ये load है समझो ऊपर से. There is a load here, and due to the load, the beam will bend. And due to the bending, there is a possibility of cracks. ऐसे cracks आएंगे ना यहाँ. So the cracks are developed due to the bending stresses. So generally cracks are developed due to the stresses. Stresses are developed due to the load. So loads are causing stresses, stresses are causing cracks. Okay. ऐसे करता हूँ मैं. Load, stress, and then cracks. So as you said, it is a psychological also. There will be fear that if structure is showing cracks, that means there is likelihood of failure of structure. So you will also have a fear in your mind whether this structure will fail or what. So there is one more point, psychological, and definitely, as you said, a functional part, we can say. So due to the cracks, there is a possibility of corrosion of the reinforcement due to the environmental, we can say, attack on that. And that's why crack width is also important, and this is also serviceability criteria. So these are the two important serviceability criteria: deflection and crack width. So we have seen stability, we have seen serviceability. So that means we can say if the structure is giving permissible deflection, we can say it is okay. But if the structure is giving too much deflection, too much sway, we can say it is unstable structure. So it depends on the calculations of the deflections, whether it is stable, unstable, or serviceable. Then second point is strength of the structure. Strength मतलब क्या है बताओ?
Ability to sustain the load.
Yeah, ability to sustain the load. Now, how will you prove in the technical language? So how we are taking care of the strength. So generally the strength of the members, the more appropriate word would be strength of material. Strength of material, okay, is the right word. So whatever material you are using in the structure, either it is concrete, steel, or if you are using timber or any other materials, the strength of that material should be such that it will not crack, isn't it? So can you give me the example, matlab, how we are taking care of this? See, यहाँ कैसे हमने किया सर्विसेबिलिटी में एक्चुअल डिफ्लेक्शन निकाला through our manual methods, book methods, or software methods. I have calculated actual deflection and I have checked the actual deflection with the permissible deflection given in the code. Yes. So I have calculated actual deflection, and actual deflection should be less than permissible deflection given in the code. So ये मैंने किया, and this criteria is satisfying my serviceability issues. Okay. तो ये this is my technical way. Actual deflection mathematically calculate करो और software से, and then compare with the code. So this is a technical thing. Or similarly, you calculate the actual crack width. Crack width समझो WCR actual less than WCR permissible as per code. So this way we have taken care of the serviceability. Now how you are taking care of the strength of material? So strength of material is something related with the In IS 456, all of you know that in IS 456, we have learned limit state of collapse. Which is nothing but the strength criteria. Okay, this is our strength criteria. So in IS 456, there is one term limit state of collapse. There is second term limit state of, let me say LS, limit state of serviceability.
Serviceability.
So serviceability we have already seen. Now what is limit state of collapse, which is nothing but strength of material. So how you check it actually means, what comes in your mind whenever you say strength of material or strength criteria?
Material
Tension,
properties.
Compression, torsion, and flexure.
So I would say in simple terms, stresses, whatever stresses comes in the materials, stresses, that is actual stresses. Why there is a stress in any material? Due to the
Load.
So loads are creating the stresses within the material. So you need to actually calculate the stresses in any material, and the actual stresses should be less than permissible stresses given in the code. Yes. So ये simple term है, we can say. So you should calculate the actual stresses within the material and check with the permissible stresses given in the code. Now you should know why stresses comes in the structure or members and what types of stresses are there in the structure. And you calculate those stresses as per the mathematical calculations and compare them with the codes. So can you tell me what are types of stresses? Example दे दो stresses. है क्या पता?
Compression stresses,
Shear stress.
tensile stress, shear
Or
stress.
bending stresses.
Bendings is correct. So let's say, for example, simple. Let's say you are putting force like this. इस पे ये column है समझो, ऊपर से load आ रहा है. So what stress will come in this member?
Compression stress.
So I can say generally stress is denoted by sigma. As it is actually axial member, I can say A use say sigma axial. And is it a compression or tension in this?
Compression stress.
So I can say this is nothing but a compressive stress. Okay. So this is a technical term generally used in codes. So compressive stress. So this is one kind of stress. समझो और एक है stress. Let's say there is a rod, steel rod is there like this. And I am pulling this stress. समझो कुछ तो load लगा रहा हूँ मैं इधर. और ये मेरा एक steel rod है. So what stress will come in this?
Tensile stress. Tensile stresses.
Sigma and axial also, because it is also axial member. Sigma AT, I can say tensile stress. So these are the axial stresses, we can say, either compressive or tensile stress. There are some other stresses.
Shear
Like,
stress.
okay, so let me take an example of beam, simple beam. समझो ये मेरा beam है. ऐसे कुछ तो simply supported beam करता हूँ मैं. This will bend, yes or no? ऐसे कुछ तो bend होगा. Okay. So it will bend. And due to the bending, कौन से stresses आएंगे? So there will be bending stress, sigma B. लेकिन whenever beam bends, what happens to this top line? इस यहाँ क्या आता है? Compression. Huh?
Compression stress.
Okay, so in simply supported structure इसमें compression आता है. Let me denote like this. So it is a compression at the top and bottom को क्या रहेगा?
Tensile stress.
Okay.
That means there are two stresses. Bending stress में sigma B compressive मतलब bending compression stress. So I would say this is bending stress in compression. Bending stress
in compression.
in compression. And ये टॉप को रहेगा जनरली, ये टॉप ये, एंड एट द बॉटम क्या रहेगा, सिग्मा बी टी, बेंडिंग स्ट्रेस in tension. So there may be bending stresses also like this, axial stresses, tensile or compressive, or bending stresses, tensile or compressive. And there is one more stress, क्या रहेगा यहाँ, बीम में और कुछ स्ट्रेसेस रहते हैं क्या?
Torque.
बीम में बोल रहा हूँ मैं, अभी बीम में ये वर्टिकल लोड है, so what stress, so this will try to crack like
Shear.
this, shear, okay, so it will try to shear off, isn't it? So I can say there is a shear stress generally denoted as tau, shear stress. So because this supporting point will try to shear off due to this supporting condition and loads. So I can say it is a shear stress. So this is one of the type of stress. Any other stresses? So these are the general stresses actually, right? Torque or torsion, as somebody said, that creates indirectly tensile stresses and shear stresses only. So there is no any general term we use torsional stress because torsion creates additional shear stress and torsion creates additional tensile stress also. Are you getting? So there are ways of calculations. Generally, these are the fundamental stresses which comes in any structure. These are the examples. This is applicable in all types of structures, in all types of materials. Okay, समझ में है? Whatever may be the structure, whatever may be the material you use, these are the only stresses which comes in the structure. इसके बाहर कुछ नहीं है. Okay, so you should know how to calculate the stresses in the member due to the loads. For example, ये how to calculate this stress? ये इसमें क्या stress आएगा बताओ?
Load divided by area.
Yes, so ये sigma AC will be P upon area. यहाँ क्या आएगा? Sigma AT, tensile stress क्या आएगा?
Load divided by area.
Yeah, load divided by area only. Simple. Axial stress is very easy. P upon A. Sorry, bending stress कैसे निकलेगा?
Stress.
M upon Z. Yes.
Yes, sir.
So due to this bending, there will be bending moment. Bending moment upon section modulus Z. That is bending stress. अगर ये Z compression के लिए ZC ले लो और sigma B M upon ZT, मतलब tension के लिए. And how to calculate shear stress? Load divided by area, but load is shear force, right? This is nothing but shear force. So how to calculate shear force? What is meant by shear force? We will learn that in basic sessions. So area, shear force divided by area. So these are the actual calculations. Once you calculate the stresses, आपको क्या करना है? Permissible stress से compare करना है. Code में दिया है सब. So each and every code has given these stresses. Check that whether it is less than sigma AC permissible as per code. So all stresses you should compare with the code stresses. So have you got what is meant by strength criteria?
Yes, sir.
Yeah. So in IS 456, it is giving for concrete and reinforcement. In IS 800, it is giving for steel structure only, purely steel structures. And these are the two materials we are using in structures actually mainly. Then for timbers, there are different codes. I don't remember the numbers. If you want to check the stresses regarding the timber structures, you can refer their codes in timber. They are available in Indian codes also and other international countries also. So I would summarize this as, see, today's session is very important. You should use these basics whenever you design any other structures, bigger structures. Now I would say strength of member is nothing but actual stresses, whatever may be the type of stress, should be less than permissible stress given in the code. So you use for different material, the codes are different. So this is the strength of members. So these are three important things actually we take care. We are more concerned about these parameters: serviceability, strength, and stability in structural engineering. Then durability, cost, and synergy, they are important, but we are not doing much in this part. We are doing much in this area. This A part is very much important, 1, 2, 3. Now just go to the durability. Now, can anybody tell me what is meant by durability? क्या मतलब है इसका?
Life of the structure.
Yes, something life of the structure. You should design the structure such that the life will increase. क्या क्या करते हैं generally? Durability में हम, how we are taking care of the durability of structure?
Use richer mix.
Hmm?
Use design mix.
So durability में
Proper clear cover can be provided
yes.
to increase the durability.
One important point is clear cover should be sufficient. क्योंकि if you don't provide clear cover sufficient, what will happen? Clear cover नहीं रहेगा, समझो beam के reinforcement को या column reinforcement. If there is no sufficient clear cover, what will happen?
Corrosion
Proper
of the
bond-
reinforcement take place.
Yes, corrosion will takes place.
Proper bonding.
One first point, there will not be enough sufficient transfer of the force. समझे ये मेरा cover है और ये sufficient नहीं है, समझो यहाँ तो there is a possibility कि यहाँ cracks भी आएंगे पहली बात तो, और through this crack then the air will pass into this air and moisture, and this will corrode the reinforcements. As the reinforcement corrodes, its life will decrease. So clear cover is one of the important criteria. So it may be for slab. It is given where it is given. Clear cover.
Code.
It is given in the code. So that means durability is taken care by clear cover, and which is available in the code. Second point, any other point? Somebody said rich mix. Yeah, that is also good way. Rich mix means concrete grade should be high. ये भी एक अच्छा है parameter. So it is better to have, for example, do you know in coastal region when there is a sea, coastal region, पता है क्या? इसमें क्या करते हैं? The grade of concrete should be higher than the dry zone. So there is a state which is dry, there is no sea near to that, then you can have. So as per our code, minimum grade of concrete is M20 for dry zones or dry cities, and M25 grade is for coastal region like Mumbai or other coastal
Bombay.
region in India. Yeah. So, or M30 grade is also used for minimum grade for water tanks, because it is continuously in contact with the water. इसके लिए minimum criteria दिया है code में M30 for water tanks. Okay. So these are the, we can say, durability criteria. Due to that, the structural life will increase. So these are the two parameters we can say. And there is one more parameter which is not structural but functional level. We do the painting of the, so we do the plaster to the members. Then we give the painting to the members, epoxy paint or general paint. In steel members, we give the epoxy painting. First we give the red oxide, then epoxy paint, like that. So these are the things generally used to increase the life of the structure, which is durability criteria. Technically term, we can say in codes it is given clear cover, then grade of concrete, these criteria are given. And Non-structural criteria may be painting of the structure, plastering of the structure, like that. So this is nothing but durability. और क्या है? Cost. So cost, see what is this parameter, cost? Yes.
Economical point of view.
Yes, economical point of view. So whatever system you are proposing as a structural design, it should be give a less cost. So ये generally क्या होता है? See, there are many solutions to a single problem, as I told you. अब जो एक building हमें design करना है, if you want to design a building, let's say high-rise building, then you can have a lot of options. Let's say there are 4 to 5 structural engineers are there, and they are given the same problem of design of high-rise building. So let's say the architectural plan is same, and 5 consultants are there which are given the structural design. Do you think that all the structural designs are same?
No, sir.
No, sir.
Do you think that the structural designs given by all the engineers are unsafe?
No.
That means they give a safe design. There is no problem because they will follow the codes, they will use the softwares, they will check it, whatever. So they are taking care. But why then designs are different?
Safety factors.
Actually, see, designs because generally I can say as the architectural part, architectural engineering we can say is a creative field. Architect is a creative field. Similarly, actually structure is also creative field. So, and as there is a creativity, then there are a lot of possibilities of creativities. See, let's say in one building, one person is proposing say 100 columns. One structural engineering is proposing 100 columns. In the same kind of building, the second person is proposing only 50 columns. Third engineer is proposing 75 columns. So there is a possibility that people may have more columns, some will have less columns. So अगर ज्यादा columns रहेंगे तो beam span कम रहेगा और कम columns रहेंगे तो beam span ज्यादा रहेगा. Then there is a possibility that people are putting shear walls. Some are putting 10 shear walls, some are putting 20 shear walls. So you don't know what kind of scheme or structural theme will come out of the creative mind of that structural engineer. But whatever may be the creativity, if you compare the cost, समझो, as I said, first structural engineer, second structural engineer, third structural engineer, समझो 4 structural engineer है. If first one is giving 1 crore price, second one is giving 1.2 crores, third one is giving let's say 2 crores, and fourth one is giving 3 crores. So who, as a client will choose first one or which one? को किसको choose करेगा? Hello.
First one, lower side.
Yes, generally client is always happy with the low cost of the project because he gets more profit or
Profit.
benefit. Profit के लिए तो चल रहा है, मतलब this is a business actually, and as we are part of the businesses, as we are the stakeholder of the business of client, we can say projects, we should take care of the cost so that if you say save the cost, you can get the part of it, whatever safety is there in your fees, and you will get more jobs. So you should always make sure that your structure is cost effective. And for that, generally what is done, you can have 2-3 options actually. So as I said that there are 4 structural engineers, but I will say structural engineer is only one. Let's say we are structural engineer, but we are giving 3 to 4 solutions. We are doing the model, 4 models or 3 models, and I am checking the safety first. Once I check the safety, I will calculate the cost of the project, and whatever may be the less cost, I will choose. So same engineer can have different options of the structure design, and he will choose the cost effective solution. So this is generally done for major projects through value engineering. Actually, this part is generally taken care in value engineering meetings or options, we can say. it is not necessary that your first attempt will give you less cost. You need to try 2 or 3 options, and then you can understand whether this is cost effective or that is cost effective, like that. So this is the one case. Generally, we prepare different models in this. Synergy part, do you know this? What is synergy? हमने discuss किया था कि I think last time discuss किया. Synergy, do you know? Do you know this term? So in general meaning of this, not word to word meaning, but synergy matlab what we are doing. See, last time I have taken example of marriage hall. Yes or no? Hello?
Yes.
So marriage hall, we have
Functional point of view.
so functional part we are taking care. So say there is a possibility क्या होता है बहुत बार whenever you work and the architects are asking you certain things, and as a structural engineer you may say that I don't want to give that. So you may say that, let's say this is 10 meter by 10 meter marriage hall. And as a structural engineer, generally what happens, structural engineer is always happy with the lesser spans. He is not interested in giving more span, because if the span of the beam is more, then it will give more deflection. So there may be serviceability issues, or the beam depth is more. The cost may also go high. Whenever you do bigger span structures like this, 10 meter by 10 meter, there is a possibility that cost will increase, then we can say deflection will increase, and you need to give more depth of the beams, like that. So you will definitely try to avoid. And as a structural engineer, I am say that can I give a column here? ये समझो मैं this is our marriage hall, let's say. यहाँ कुछ तो stage है, समझो stage. This is a plan, and I am asking the architect, please allow me this column so that I will have small span beams. ऐसे कुछ तो रहेगा. I can have these beams, and I can have these columns like this. तो मेरा कितना span होगा beam का ये? Beam and slab span कितना रहेगा? 5 meter रहेगा ना? 5 meters, 5 meters. So definitely as a structural engineering solution, it is always to have a lesser span of beams, more columns, because structure becomes more stiff, stable, and there are less serviceability issues. क्योंकि जितना span बढ़ा उतना serviceability issue may be there, and cost may be हो सकता है कभी-कभी problem. As a structural engineer, I know that it is really good solution from the structural point of view, but is it really good solution for functional point of view?
No.
Yes.
It will be bad.
So it will be bad,
It also-
even though your structure is very safe, maybe cost effective, but still it is not fulfilling the functional requirement. That means every structure has its own requirements. I understand that you are, as an engineer, more focused on the safety and more focused on more safety. So, but it is really not good structure. So the engineer who is taking care of the synergy part of the structure means he's taking care of the functional part of that particular structure or architecture's requirement in such that it satisfies its full. So as I told you yesterday, that stadium structures. In stadium structures, you will see that all structures are like cantilevered structures. There is no column in front of the view. So stadium structure, so it has its own requirement. So you may need to design many bigger cantilevers. You cannot say that the cantilever is very high, 6 meter, 7 meter cantilever. It is better to provide one column there. See, it is of no use. I think last time I have shown you in my session that cricket stadium structure. I'll just उसमें मैंने दिखाया था. See, you can see this structure. See this cantilever. is 8-meter cantilever, 8 meters. Definitely designing such a big cantilever will not be a choice of structural engineer in general. इतना बड़ा कैंटिलीवर, लोग 2 मीटर किया तो भी दे फील कि अरे इतना बड़ा कैंटिलीवर, 3 मीटर तो और भी उसको बड़ा लगता है, बट 8 मीटर सी, बट यू कैनॉट डू एनीथिंग because otherwise its functional requirement will be we can say violated or spoiled, we can say. So if there are challenges like this, you need to do that, otherwise the stadium will not say fulfill the functional requirements. So these are the cases, and whatever you are doing for this, it is something related with the synergy part, we can say. Okay, synergy का मतलब समझ में आएगा in general. And these are the parameters we are considering in structural design. All of you got this?
Yes, sir.
So please take a note of all this actually. You can refer the video or whatever. See, these are the only 6 parameters you should consider in your design. Don't forget any of this. Without this, the structure, we can say your design will not fulfill. Stability, highly important. So these are the steps. You should first take care of the stability. Once you make the structure stable, then you can design the structure and analyze the structure. An analysis is done to calculate the stresses. Okay, so then once you calculate the stresses, you take care of the strength criteria, then you calculate the deflections for serviceability criteria, then put sufficient cover for durability criteria, calculate the cost of the project to check the optimum cost, and in coordination with the architects, make sure that architects' requirements are satisfied in a better way. See, it is not always that you can satisfy all the requirements of architects. No, there is a possibility that architect is asking some non-technical issues which may have a problem to the structure in future. In that case, don't allow the architect's points. There you can have your strong points. It is not necessary that you should agree 100% architect points. They see many times architect is asking like anything. Then also it is not possible to follow that. So it is, we can say, a judgment. You will learn that through experience, through coordination and communication with the team people. So these are things. Now in our basic sessions ahead, we will learn all this in detail actually. So how to calculate the stresses, what is given in the code, and so on. So a lot of things are there actually to learn. Now, so let's understand the structural department workflow actually, how we work, where it starts and where it ends generally. So as I told you, we get the architectural drawings. It may be plan, elevation, sections like that. And there is a site layout also, building line, site layout. Then parking layout is also there in the buildings. And column positions, sometimes architect give column positions and orientations also, and offset side also, number of floors like that. So we get that architectural drawings in the beginning. Once we get the architectural drawings, then we also get the geotechnical report, and we have already learned that we can get these SBC values, depth of foundation, then water table, and CN5 values, which are required for retaining wall design. So we get all these data through the geotechnical reports. And on the basis of this, we prepare the design basis reports. Anybody knows what is meant by design basis report? We are going to learn that, but I'll just brief you. We give the brief introduction of the project in the design basis reports. Then we give the material properties like what grade of steel, what grade of concrete you are using, what are the loads you are considering, dead load, live load, earthquake loads, like that. What reference codes you are using for the design, that we put here. So this is our basis for analysis, for design, for drawings, everything. This is the basis. Once you do the design basis, then we prepare the structural general arrangement drawing. So what we do in structural general arrangement drawings, we put the column locations, columns on the plan. Let's say take an example of building first. Putting the columns on the plan, putting the beams on the plan, shear walls, and give the name to the beams like B1, B2, B3, or columns C1, C2, C3, like that. So we concept drawings. Structural GM is concept structural drawing. We decide the load path, one-way slab, two-way slab, like that. So we mark that on the plan. So this is the structural GA start. Then second point, once you prepare the structural GA drawings, you approve them from the architects, and then you prepare the ETAP model. So ETAP model means we can say preparing that column, beam, slabs, modeling everything there, beam, slab, columns and footings, supports, then putting the concrete material, steel material, giving the sizes to the beams and columns, like that. So everything we do, we give the load in the ETAP model, we give the load combination as per the code. So this model, we call it as a mathematical model. So once you put this, then we do the analysis. So once application of the loads are done, you can do the analysis. Analysis means what? What do you understand by analysis? So analysis means generally we apply the load on the structure. So we first generate the frame. This you'll learn in the ETAP modeling sessions. But analysis means, in simple, I would say, first you create a structural arrangement. Let's say I want to construct a room, single room RCC structure. So what I will do, I will take what height of the building, height of the room I want. Let's say I want 3 meter height. What is the width of the room? Let's say 4 meter width. So what I will do, I will put the columns, then I will put the footings here below this. And I will prepare this model. So this drawing is called as the mathematical model. Okay. Then I am putting the gravity load, self weight. Gravity load means dead weight, then live load on this room. So this creating this geometry. So mathematical model means geometry. I have created the geometry that as per the functional requirement, geometry and dimensions and everything. After the geometry, what I am doing, I am putting the loads on the structure. And after the load, what will happen? Due to the load, what will happen to this?
Stresses are developed.
Yeah, so first point I would say it will deflect. Okay, so it will deflect. So due to the load, there will be deflection. And due to the deflection, there will be bending moments. There may be shear force. There may be axial force P. So what will be there? Deflection, then bending moments B, M, shear force SF, axial force in column AF. And due to this bending moment, shear force and axial force, what will be there? Stresses, as you said. Bending stress, axial stress, and so on. So preparing the geometry and mathematical model, applying the load and getting these deflection values, bending moment, shear force values. This total process we call it as analysis. Okay. This is analysis. Now there may be vertical loads or there may be horizontal earthquake loads also, wind load like this. All of you know that earthquake load is horizontal. H, let's say this is W. So there will be bending moment as per the load conditions and everything. So this total process we call it as analysis. And once you get these values, you get the stresses. And once you get the stresses, what you do?
Analyze the section.
Yeah, so design the section generally, we can say, design the sections. So design columns, design footings, design slabs, beams. So how we are designing this? Designing on the basis of stresses. Yes. So we are giving some size to the sections. Size of column, we assume certain size. And on the basis of stress, what we do? So, okay.
Axial load divided by area.
Yeah, so see, we have got bending moments, we have got axial force, we have got shear force. Okay. So bending moments, I will get bending stresses. Axial force, I will get axial stresses. Shear force, I will get shear stresses. So I will calculate actual stresses and will compare in the code with permissible stresses. I know that for bending actual stresses, I want sizes of the members because P upon area, axial stress sigma A is nothing but P upon area. But how you will get this area? You need to assume certain size. Area means area of cross section. So if it is a column, then area of cross section, let's say B into D. So you assume some B and D, then calculate actual stress and compare with permissible. If your stress is more than permissible, let's say sigma actual is more than sigma permissible, what will you do?
Increase the low area.
Increase the area or cross section. So increase area, that means increase B or D, whatever you want. And then you can decrease this value. So this is the way the design is done. Yes, we will learn that in detail. Try to understand the concept holistically. Then we do the design of all members. So designing we can do manually, or you can use Excel programs, or you can use RCDC software. For analysis, we will design the members. Then after the design, definitely we need to prepare the drawings, structural drawings, all detailing and everything. So we will learn that ahead. Site visits generally are required. It is very less part, but okay, it comes. So this is the structural engineering workflow. And within this workflow, we are going to work in our training program. So we got this, and as output, we generally give the design basis report and structural drawings to the. We even give the output of ETAP model also. These are type of structural drawings. So any questions? Any questions from you? We are going to conclude the session. Before that, any question with respect to today's session? Today's this topic is very important because, see, as I already told you many times, there is no clear picture of the structural engineering in front of us. So as I said, we have learned the things in many parts in school, college, or through books, but we don't know integration of all this. And this today's session should help you for integrating the overall structural engineering process. And every structure lies within this framework only. There is no any other way. These are the only things actually. Now, okay, there may be certain more complex mathematical calculations or softwares are there, but the basics is same like this today. So please, any questions?
No, sir.
Okay. So from next session, we will start with the basics of the structural engineering in detail. We learned a holistic picture today. Now we will go in detail regarding the analysis, design, and other things. Okay. So anybody is having specific questions regarding basics of the structural engineering? See, why we are taking that basic sessions, because many people might have forgot the concepts of structural engineering. So we are trying to refresh that, but maybe in a different way, more we can say conceptual point of view and decision making point of view in the projects. So do you have any specific we can say basic concepts which needs to be covered in the training program? From your point of view, I'm just asking you. Any specific that you forgot this, or you don't know how to do that, or whatever it may be? है क्या किसी के दिमाग में क्या मतलब स्ट्रक्चर्स में सीखना है, बेसिक्स लेवल पे बोल रहा हूँ, या आपको आता नहीं है, यू डोंट नो, एटलीस्ट क्रिएट क्वेश्चंस कि ये हमें नहीं आता, ये समझ में नहीं आता इस करके. Okay, then shall we close today's session?
Okay, sir.
Thank you all,
Thank you, sir.
and good night to all of you.
Good night, sir.
Good night.
Night.
Thank you, sir.
Thank you, sir.